Alright, so in this tutorial video, I'm going to be going over the checkerboard cipher, which is a new cipher that was added to Science Olympiad in the 25-26 season. Basically, I'll first go over how the cipher works, and then after that, I'll do this example problem. So the main aspect of this cipher is this table, which is very similar to the Paulbus table in the Nihilist cipher, except in the Nihilist cipher, if I pull up one right here, uh, you have the numbers 1 through 5 in the first column and in the first row. But in a checkerboard cipher, uh, you're going to have a row key and a column key for the first row and column. And this row key and column key are going to be basically their own keywords. So I could type the word hello here as the row key, and I could type the word walks as a column key. And how the cipher works is if I have the letters HW for the first character, and in the table HW decodes to P, then I would put P as the first character in the decoded message. So right now, you know that the cipher has already been encoded because you see a bunch of sets of two letters back to back. So now the question is, how do you solve the cipher? The first thing you're going to want to do is fill out the center of the table. And how you do that is first you type in the keyword. So in this case, it's father. And let's say the keyword has repeat letters. So you could ask, what if the keyword was the word hello, like I used that word before? Then what you do is, since there are only 25 spaces in the center of the table, so you can't use the same letter twice, you're going to have to get rid of the two L's and only have one of them. But in this case, we don't have any repeat letters, so we just type out the word father. And then after you do that, you just go through the rest of the alphabet in order, skipping the letters that are in the keyword itself. So I would do B, C, D, skip E and F because they're in the Paulbus keyword. So you'd go straight to G, skip H because it's in the Paulbus keyword, and then you'd go to I. And one thing to note about filling in the alphabet here is that you only have 25 spaces since you have 5 columns and 5 rows. And since there are 26 letters in the alphabet, what you have to do is you have to put 2 letters within 1 space. So whenever you fill out this checkerboard cipher, one thing you have to note is I and J. The letters I and J are going to be in the same space. So think of the space, even though I just wrote the letter I, this space represents both the letters I and J. So how that would work when you're decoding the cipher is, let's say I'm decoding the checkerboard cipher and I decode the letters SH, and then I get the letter I, but it could either be I or J since they share the same cell. And then you get NE. What you have to do is use context clues to determine whether or not it's an I or a J, because they both share the same cell. In this scenario, it's very obvious since this spells out the word shine. There's definitely going to be an I here. Very rarely would you get a letter J instead of I when you're decoding like a cipher, just because the letter J isn't that often. But sometimes, obviously, you're going to have a scenario, maybe if you have like a word like jump, we're going to have to recognize that you're going to put J in a space instead of the letter I. So yeah, just keep in mind that I and J share the same space in the checkerboard table. So after you put in the I, you skip J because I and J share, and then you go to K, L, M, N, O, P, Q. You skip R because it's in the Paulbus keyword, so you go straight to S. You skip T because it's in the keyword, and you go to U. Then you do V, W, X, Y, Z. And that's how you fill out the center of the checkerboard table. The next thing you're going to have to do is figure out both the row key and figure out the column key, because you are not given that information in the Science Olympiad test. So in order to do that, you're gonna list out all of the first letters that you notice in the encoded message, and you're gonna list out all the second letters in the encoded message. And then you're gonna have to rearrange those letters into words that make sense. So I'll just show you how it works in this example. So I noticed that the letter L is in the first of the two characters. If I go here, the letter G is a first letter. What else? The letter R is a first letter, so I'd put R. The letter E is a first letter. And A is a first letter. So now that I have a set of 5 letters, I need to rearrange these in a word that makes sense. And right now, the most obvious word for me looks like the word large, which I'm pretty confident is going to be the row key. And now you just do the same thing for the column by looking at the second letter instead of the first one. So I'll list out the second letters. I see an I see a C, H, keep on going. I see a W, so I put W, and I see the I don't think I see any other letters. So since I only have 4 letters, I know that one of these letters needs to be repeated twice in order to create the 5-letter word. And right now, the word that I'm thinking of is which, since it contains the letters W, I, C, and H, which were in the letters I listed out before. And now that we've filled out the entire checkerboard table, the cipher is very easy to decode. So in order to decode the cipher, what we're going to do is we're going to look at every set of 2 characters and figure out what letter it decodes to. So we can start with Li. So if we go to Li in the table, we can see that it decodes to T, because L is in the row key and I is in the column key. So we go T here, and then LC decodes to H. And now we go to LH, and you'll notice something interesting, which is that LH can either decode to A or it can decode to E. And right now, it's not that easy to figure out which letter to use, especially in a lot of these other scenarios. And this is true for every single letter in the row key. Whenever a letter in the row key has an H as a second letter, there are 2 different options for what letter is the decoded letter. So what I'm going to do is every instance where there's an H for the second letter in the set of 2 characters, I'm just going to do those decodings later because it's not exactly sure what letter you should pick for a specific context. So I'll just skip all the ones with H's. I'll go to GC, and that decodes to S. I'll skip to LW, and that decodes to F. And let me just reiterate the issue with like the H endings. So like I said before, LH can decode to either A or it can decode to E because LH, LH. And that's why we're skipping all the instances where H is the second letter because it's very hard to figure out what letter that would be in a lot of instances. So we'll keep doing the sets where H is not the ending character. We'll do Li, which decodes to T, AW, which decodes to R, GC, which goes to S. And I think you get the gist. I'll just do the rest on my own, and we'll go from there. Okay, so I filled out all the sets of letters that don't end with H. And these obviously were the easiest letters to fill out because they aren't ambiguous. You don't know. It's not like you have to choose between with 2 options of letters given a specific context. So now that we're done with that, what we're going to do is we're going to go back to all the sets that end with H and try to figure out what letters they actually decode to. And I think the best way to approach this is kind of like an aristocrat, where you try to find patterns in like phrases or like words and try to determine what words certain things are based on what's easiest to see. And right now, something that's very easy for me to see is this area right here with the RYTHI. That looks a lot like the word everything, especially since LH, it can either be A or E. And since I'm pretty sure it's everything, we're going to fill LH with E here. So we got EVE, everything. So that was an easy word for us to get. Now we have everything, and then we have AH. And if we go to the table, AH can either decode to B or it can decode to G. I don't think it's G. I think it's more likely to be B because we have this word by. And if I go down here, this kind of looks like the word addition. So LH, I think, is more likely to be A. So we have LH is A. And now I kind of see additional right here because LH here could also decode to A. And RH can decode to N. What else can we see? This kind of looks like the word require here. So LH is E, require. RH can either be K or N. I think it's more likely to be N, so this would be requiring. This looks like simplifies, so I think this would be E. And then requiring me to, remember LH can either be E or A. So I think this could be learn right here. Requiring me to learn LH can either be A or E, and then RH can either be K or N. I think it's more likely to be N because N is a more common letter. Requiring me to learn 10. I think this is probably 10. 10 additional, and then same thing here. RH, I think it's more likely to be N than it is to K because N is a more common letter. So confusing. This looks like the word confusing. Confusing, and LH, it can either be A or E. I'm not sure what it is yet. GH can either be P or U. If I put U here, I don't think it's U because neither A or E work with it. So I'm going to try P, and I think this is the word steps. So 10 additional confusing steps. And now we can go back to the beginning. We have two LHs. I think this first LH is probably E, so that we get the word the, one of the most common words in the English alphabet. And now we have two GHs. LH can either be A or E. If we try E, I'm not really sure about this area, to be honest. GH can either be P or U if we look at the table, right? GH, either P or U. So if we have a vowel here, like either A or E, I think it's more likely to be a consonant right after it. Because we have this word the, and now we have a new word. And if we try U here, the epis. I don't think that's a word. We can try two P's. Or we could try replacing LH with A. And now we get the word apps, which kind of makes sense. So I'll stick with that for now. Now we have another RH, which can either be K or N. I'm going to stick with N because it's more common. LH can either be E or A. I'll stick with E for now. EH can either be W or Z. Since W is more common, I'm going to stick with W. And now we get this word new. The apps, new. Now LH can either be E or A. The apps, new feet. That doesn't make sense given the context of like apps. So I'm not sure about it. I think this would probably all be one word. Because we have a new word here. And we have the word new right here. So I think this whole thing has to be one word. You can try EA here for like feet. And now this looks like the word feature. So the app's new feature simplifies everything by requiring me to learn 10 additional confusing steps. So yeah, we were able to successfully decode this checkerboard cipher. It was a lot harder, specifically because this keyword, the column key, had two H's in it. So there were a lot of missing gaps that we were left with. For a lot of checkerboard ciphers, I feel like, especially early on in the season, I don't think they're gonna stump you like this. You're probably more likely to have no repeat characters in the row and column keys, and in that case, you don't have to guess anything. You can just like fill everything out normally without leaving any gaps. But in this tutorial, I kind of went with a tougher example just to show how you can deal with that if you ever face that issue, I guess. Yeah, hopefully you're able to decode checkerboard ciphers now. Something else that I wanted to mention is that the TOBE's website has its own tool for you to create your own checkerboard ciphers. And it's especially useful because after you create one, like after you put the message that you want, after you put all the keywords, it has a tool that allows you to view the best way to decode the cipher. And if you're really stuck on checkerboard cipher and you're not sure about how to approach it, I would definitely recommend using this tool and looking at how it explains how to solve the cipher. It goes through how to find the row and column key. It goes through how to fill out the Paulus table, and it also goes about how to decode the letters themselves.